In question 5a, when the golf ball is first dropped, there are no resistive forces acting on the golf ball, as there is zero velocity. Therefore, the only force acting on the golf ball is weight, which means the acceleration would equal g, or 9.81 meters per second squared. In 5a II, at terminal velocity, the net force is equal to 0. And for the net force to be 0, the drag must equal the weight. In 5a III, the question asks, explain which of the two balls reaches the greater terminal velocity. So we know that drag increases as the velocity increases, and the golf ball, which has the greatest mass, has a larger downward force, therefore must have a larger drag to increase the terminal velocity. All this means that the golf ball will have a larger terminal velocity overall over the tennis ball.
For question BI, we know that the forward force is 3,200 newtons and the drag force from the graph is 2 kilonewtons, which is 2,000 newtons. To calculate the net force, we do 3,200 minus 2,000. This gives us a total of 1,200 newtons. In order to calculate the acceleration, we then do F equals ma, which works out at 1,200 divided by 8,000, which gives us an acceleration of 0.15 meters per second squared. Question BII asks us to explain why this lorry cannot travel at a speed of 40 meters per second on a level road. This is because if we look at the graph on the previous page, at 40 meters per second the drag equals 5,000 newtons, and as the drag would be greater than the forward force, it cannot be travelling forwards. Question C asks us to describe and explain how a seatbelt reduces the force on a driver during the impact of an accident. During the impact, the seatbelt stretches, which increases the stopping distance. As the work done will not change, and as W equals Fx, when the distance increases, the force must decrease in order for the same work to be done.